but a lot of people sometimes, you know, they know how to do. So it's a lot of new ones here. So if you're new, come right here, subscribe, you know, and follow me on all social media. For the other people be here, or for the other people be donating me, thank you so much. Like I always say, you know, I have to keep it real. It's the people who donate me so much, you know, to the point where the last donation that you guys sent to me, I just look at it like, man, this is a lot of money. Maybe you should just do some of the refund. But I realized because the work that I put it in. So I appreciate, thank you so much again. You know, it means a lot to me. You know, your presence, I really appreciate it. I see you guys, you know, I'm nothing without you. Thanks a lot. Let's get started. So now they say parallel place capacitor. So we have a capacitor, okay? Has a place of area. So we have, that capacitor have a cross-section area of 0.4 meters square. And the place separation is off. So let's say, for example, let's assume, okay, let's say this capacitor, the first one, and this another one. This is a roughness case. The parallel, oh, how did I say? Parallel. Okay, cool. So parallel capacitor, for example, if somebody give you something like this, let's say this is a capacitor, like this is a capacitor, you know what I'm saying? And then you have another capacitor. So let's call this capacitor 1 and this capacitor 2. Let's say roughly, you know what I'm saying? So these two are parallel because look, it's like this. But for series, it's something like this. Let's say this capacitor 1 and there's another capacitor 2. You know, so now, so let's say the parallel capacitor place has cross-section area. So we have a cross-section area equals 0.40 meters square, and the plate separation mean the separation between plate. For example, let's assume this, the distance of separation between the plates. What is the separation between the plate? Is, so distance of separation is 0.2 easy millimeters. So we have to change this to meter. So how are we going to change to meter? So we're going to have to multiply by 10 power negative 3 meter. Okay, now we go. What do they want? They also give you permissivity. Okay, so now we're given also permissivity, which always constant. So this is constant permissivity times 10 power negative 2 Coulomb square in the Newton terms meter. So we have a permissivity, and then what is the magnitude of electric field between the plates? This is very, very easy. The A, magnitude of electric field. So electric field, let's go for A. Electric field, we know, equal to V over the distance of separation. Potential difference, we do have. What is the potential difference? Our potential difference, where is it? What is the magnitude of electric field between this? Where is potential difference? We don't have a potential difference. Oh, this one right here, I don't read careful. So we have a potential difference. Okay, thank you. So our potential difference, we have equal to 9.01 volt. So now we're going to say 9.0 volt times, instead 9.0, excuse me, volt. And then we over distance of separation. What is the distance of separation? This separation is 0.2 times 10 power negative 3 what? Meter. So now put that in the calculator. If you want a calculator, this is going to give you 4.5. So this is going to give you 4.5 times 10 power 4 volt per meter. Volt per meter. You know what I'm saying? Or you can say Newton per coulomb. You know, Newton per coulomb. You can say volt per meter, or you can say Newton per coulomb. Man, what do you mean now? What you kind of have like different. You can say also Newton per coulomb also. It's acceptable. Newton per coulomb. So either of the two. Okay. Okay. Now we go. So now we go for it because we say volt per meter or Newton per coulomb. Be the same thing. Both are units of that one right there. You know what I'm saying? Now we go. You know why we say that? Just for the sake for somebody people don't know. Also, electric field could be equal to force over quantity of charge. The same electric field. You know what I'm saying? It could be different potential difference over distance separation or force over quantity of charge. But for this case, we did not involve force because it has nothing to do with the force. Okay? So that's why I had to take. So either you can take Newton per coulomb because this is Newton per coulomb, or you can say volt per meter. So either way. So I just decided to take Newton per coulomb. It's fine. Now let's go for B. What is the capacitance of the capacitor. So capacitor, the capacitor, we have a formula for capacitance. Very small, simple formula. Okay. Sorry, just a second. Thank for your patience. Okay. Now, capacitance, we say capacitance equal permittivity, cross-section area times permissivity over the distance separation. So that's how this will be. This is how you get the capacitance. You know, or whatever information they give to you, you can use this. You know what I'm saying? It depends on your information. So capacitance equal to the cross-section area times the permissivity over distance separation. Okay, now, do you have a cross-section area? Oh yes, it's given 0.4 meters. So this could be capacitance equal to 0.4 is in millimeters, so it's fine. We don't have to change anything. Okay, permissivity is always constant, 8.85 times 10 power negative 12, and then we over distance separation. Now distance separation, we have it. What is distance separation? Distance separation is 0.2. So 0.2 times we multiply by negative 3 because we want to change these 2 meters, which we did already. This one here. So now what we're going to do, plug in the calculator. If you plug in the calculator, this is going to give you 17.7 times 10 power negative 80, and the unit of capacitance is farad. You know, so we got unit of capacitance. So now sometimes you can change this if you want. You know why? Because we know for facts, if this is farad, if you want to change anything to non-coulomb or non-whatever, it has to be 10 power negative 9. So if I make this 10 power negative 9 farad, mean this was going to move to the right. It's going to be 17.7, and this is going to be this MSA because we changed it to 10 power 9. So remember, still farads. So I can say nanofarad. Me if I remove this, I can say n farad. You know, n farad, and this is going to give me 17.79 farad. You know what I'm saying? For the people who don't know how to change these things, non-farad, farad, I'm gonna write to you after we finish so I can have a space here of how to change from farad, nanocoulomb, microcoulomb, etc., etc. So now for that case, we're gonna say, so n coulomb. So now for the third one, which is C, what do they want? They say what is the magnitude of the charge on each plate? Magnitude of a charger means the one Q, quantity of charger. So quantity of charger equal to C times V means capacitance and potential difference. Capacitance we have, so I'd rather take this, the one with it, farad, not non-farad, you know. So my answer is going to be as how it's supposed to be done. So this is going to be 17.7 times 10 power negative 8 times, what is the distance separation? Distance separation, we have somewhere 0.2 times 10 power negative 3. Oh, space is very enough. So I'm going to say these times, okay, let me say times 0.2 times 10 power negative 2. So our coulomb is going to be, let's plug in the calculator. If you plug in the calculator, it's going to give you 1.59 times 10 times 10 power negative 7 coulomb. Okay, so this is a quantity of charger that, or magnitude of charge of each plate is going to have. So each plate is going to have this or magnitude. Okay, so yes, so for the people, like I say, man, I hope you learn from how I do things. You learn from my methodology, you know what I'm saying? And I appreciate your praise, it means a lot. So you can share this video, it's going to be meaning a lot for me. Leave a comment, I'll be more than happy to respond to your comments, okay? So thanks a lot, and I'm going to touch here the non-coulomb, how to change from non-coulomb to microcoulomb and millicoulombs and all them. I'm going to touch here, you see, okay? Thanks a lot, and I'm out. Bye.